All right, today we're going to be looking at 9.3, estimating a population standard deviation. So it says standard deviation, but a lot of times we'll be using the variance. So you got some reading here. We're going to be using the chi-square distribution. We're going to find, I'll say chi-square. It talks about the pronunciation over here, chi. All right, so here's the distribution. Most of the time we're going to be just focused on computing this in StatCrunch, but you got a sample size of n, normally distributed, mean and standard deviation are given. Then estimating the standard deviation, you're going to take the degrees of freedom n-1 times the sample standard deviation, the sample variance divided by the population variance. The properties, it is not symmetric. The shape of chi-square distribution depends on degrees of freedom, just like the student t distribution. As the number of degrees of freedom increase, it becomes more symmetric. Chi-square are non-negative, greater than or equal to 0. So those are some properties. Let me go back. This was a little shape of the distributions with some different degrees of freedom. You can see these lines here. And then here is what one such distribution looks like and how they're finding the critical value. So this table shows you the area in the right. So area to the right of 0.05 would be here. If you want to find the area to the left where it's 0.05, that means 0.95 would be to the right of that point. And so you would look at 0.95 and you would find that degrees of freedom. Here are just some more computations showing you how to make the confidence interval for the population variance, lower bound and upper bound. Again, we're going to be using StatCrunch to compute most of this. I go through an example showing you step by step, and then directions for StatCrunch. All right, so let's jump into it.